on this computer. All right, so those of you who try to do the homework, these would have been the homework. And obviously I wanted you to do 1 through 20, and no one, not a single person in period 2 class in the year 2022, December 5th, did their homework. How pathetic. Anyways, so let's go together. It says here, what's the difference between independent and dependent events? So, well, verbally speaking, a dependent event is an event whose probability was altered or affected by a previous event. Okay? While an independent event, the current event was not affected by a previous event that occurred. So I guess what we can say is, and I'll write here. So imagine rolling a 6 and flipping a coin. Right? Imagine that. And so if I ask you what's the probability of heads given a 6, obviously the roll of the coin didn't have an effect on flipping the coin and getting heads, because the roll of the dice cannot affect the probability of getting heads or tail on the flip of the coin. So you're still gonna have half. If you just flip the coins to get heads, you still get half. So in that case, that's independent, obviously. Independent. All right. Now, the other example we have, the traditional one we have is, if they say you pick a card and it's king, right? And you don't put it back in the stack. So we say without replacement. And then I ask you, well, what's the probability of getting a queen given you just got the king? So you got the king and then you're like, okay, let's pick this in the stack. Another card, and I ask you, what's the probability of getting a queen given that the first event that's happened is king? And you will report back to me 4 out of 51, because there's only 51 cards left in the stack, because you're holding the king in hand. Remember, there's 52 cards in the stack. And so now when you look at just probability of queen by itself, the probability of queen by itself is 4 out of 52. So this will be a dependent event, because the act of king happening had an effect on queen. That's fine. So if that's true, I guess I'll write it over here. We can say the following. All right, we can say, if you remember this, I guess, and we did it in the notes. If events A and B are independent, then the probability of B given A equals the probability of B. That means that A had no effect. Else, if that's not true, they are dependent. So this were not true. And it's not true here, because if you look at probability of queen given king in this situation, they don't equal each other. So that's why we say it's dependent. Remember, the king had an effect. Now we could make that example I'm giving you, picking a card, we can make that independent. And the way we make it independent is by doing the following. So say you pick a card, and it's king, right? But now you replace it you replace it. That means you put it back in the stack. So then I ask you, hey, what's the probability of queen giving king now? Well, it's 4 out of 52. Well, originally the probability of queen would have been 4 out of 52. But in this case, the event king did not have an effect on the event queen because you reset the probabilities by replacing the king back in the stack. And so in this case, this would be independent. Independent. So usually with cards, not usually, whenever you replace the cards back, it makes everything independent. Okay, make sense? Because this is what we did last class. So it was vitally important for you to do this homework because what happens is when I review this, you have questions for me and it makes that the class worth it, you know, for me. I mean, I'm not saying it's not worth it for me now, but it also makes it worth it for you.
So if we get the number one question on the test, we can have like a written response saying that dependent.
You can also, if you can tell me verbally the following, if you can say that for that question, you can say, independent events are events that are not affected by each other. Independent events are events that are affected by each other. I think I would accept that. But if you remember the definition that I wrote there on the left, even better. Or you can even describe 2 examples to show me, hey, when I roll a dice, and then I flip a coin, the event dice, the rolling of the dice, whatever result happened, does not affect the probability of me getting heads or tail on the flip of the coin. But then you might say something like, but in the case of picking 2 cards where I don't replace the card, the probability of the second event occurring was affected by the probability of the first event because of the change in the stack of the card, the size of the stack of cards, whatever you want to say. But I want to see something that shows me you understand that being dependent, events that are dependent because the previous event had a role in changing its probability that when it was by itself would have been different. Does that make sense? That's it. Now, problem number 2, I guess I'll leave that to you. But so far we've listed 2 independents on number 1, and they want you to write 2 events that are dependent. Okay. So I've given you 1 dependent and I've given you 2 independents, right? You could do that on your own, I think. I think at this point, you know, it would have been nice to discuss and to see if somebody came up with something different. Let's go to number 3. It says, if 2 events are not independent, then the probability of A given B equals probability of B. So first of all, we can fix this. So we can say if 2 events are independent, the probability of A given B equals the probability of A. That can't be a B. That's how we fix it. That's one way. Okay. Another way is we say if 2 events are not independent, but nobody writes it this way, then the probability of A given B does not equal the probability of A. That's 2 ways we could have fixed this one. Again, guys, I can't overemphasize that the reason you didn't do your homework, there's many reasons, but probably the prime one is you didn't use your time effectively yesterday or the day before. So Mia asked me, what are you doing? I'm logging my time today. Because oftentimes we have to pick between something that's pleasurable and less pleasurable. Doing our homework is not pleasurable most of the time. It's not, unless we're looking forward to doing it. And that makes all the difference because when you do this for 20 years, when you act the way you acted today for 20 years, you might be disgusted with yourself one day or many days. Or maybe you're disgusted every single day, but you don't change. Fair enough? And this is going to come out on the video. So if your parents hear this, they're going to be like, bro, is this guy crazy? All right. If events A and B are dependent, so now they're dependent, then the probability of A and B equals the probability of A times the probability of B. Okay, simple way to fix this is no. If the probability of events A and B are independent, then you have this. Now, the other way to fix it was, what about if they're dependent? If they were dependent, then we go to the original rule. Probability of A and B is called the multiplication rule, must equal the probability of A times the probability of B given A. And I know that that's kind of sloppy. I think I can make that better. The probability of A and B equals the probability of A times the probability of B given A. So if they were dependent, that's another way you could fix this true or false. All right. Now again, guys, you need to try. I would recommend that those of you who get into the homework and who are interested and separate the time necessary for this, that you try now after I reviewed it to redo it on your own using not these notes, but the previous class notes, and see with this, obviously you're gonna have an advantage, which is okay, but see if you understand these concepts. And little by little, you start building the foundation you need to understand this. And not only that, even if you're not going to use this for the rest of your life, because it's the obvious thing you guys say, you know, you change the perspective of what you could be, plus you exercise your discipline. Okay, so the next few questions are about classifying events are independent or dependent. So now we can talk about this, right? And it says, explain your reasoning. That's the tough part. It says they're selecting the king from a standard deck, replacing it, and then selecting the queen from the deck. So when we select a card, replace it, and then select another card, would those events be independent or dependent? Independent, and it's independent for the reasons we discussed recently, right? Because now the probability of the second event is going to be the same as if you would have just done it as a first event, because we put the card back in the stack. Any questions or concerns? No? Returning a rented movie after the due date and receiving a late fee. Is that independent or dependent? Dependent, obviously. I mean, I know nowadays we don't return any movies, okay? You just like kind of like rent them, and like when it's the 48 hours are due, you can't see them anymore. But there used to be a time you rented movies from Blockbuster. Yes. And you would go there and you rent it, and then you like forget for like a week to return it. You know, I don't know. I can't remember now how many days you had to see it. And you would go back, and then they'll charge you a late fee. How the world has changed. So return or rent a movie. So this will be dependent. Of course, the late fee is dependent on the event of you being late. 7, rolling a 6-sided die, and then rolling a die a second time, so that the sum of the 2 rolls is 7. Huh? It is dependent. It is dependent. It is dependent. Because you being able to get a 7 total sum depends on what you got on the first number. You can't always get a 7. It depends. There's a few combinations. You can get a 1. No, you can't get 1. 1 and a 6. You get 2 and a 5. You get a 3 and a 4. You get a 4 and a 3, a 5 and a 2, and a 6 and a 1. But it's also possible that you get 3 and 3. So it all depends on what you got on the previous one. And also depends on what you get in the next one. That one's interesting. Rolling a 6-sided die and then rolling the die a second time. So the sum, yeah. Yeah, it depends because let's say the first event you got a 1. But then on the second event, you get a 3. Can you get a 7? No. So they depend on each other. So I'm gonna go like that and say dependent. At least on what we're talking about on our understanding. A number ball between 1 and 52 is selected from a bin. So we're picking a ball, we're putting it back, and then a second number ball selected from the bin. So what's that gonna be? Yeah, it's independent because of replacement. Independent. Now with number 7, for some reason, I feel uneasy about it because you just roll the die. Whatever you roll, you get a number. You can always make a 7 of it, but it depends on the second event now. But we don't know that until we do it. So whatever, it's not interesting. At least we're discussing it. I'm not gonna make things that difficult, but let's see. Rolling a 6-sided die, good, and then rolling the die a second time, so the sum of the 2 rolls is 7. Well, it would all depend on the second event versus the first event, because the first event has happened. Once the first event happens, then it will be dependent on the second event. Right? But we won't know that until we roll it. So yeah, they are dependent on each other. They're dependent. They're dependent. They're dependent. 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 But because I overthought this question, I'm gonna go ahead and take a look at la respuesta. That means the answer. Do you know that? Okay, Pure Math book, PowerPoint statistics, student edition. Where do I have my only if you're careful. Well, I have the teacher edition on this here, but statistics book. It takes, and I'm eating up so much battery life on my thing here, and I need it ready for ACE next class. So let me just go to that section here. And I'm getting close. No te pase. Okay, I am in this section. I tagged it, sort of. What number was that?
7.
These events are dependent because the sum of the roll depends on which numbers were rolled first and second. But I don't say first and second. Is there any way it has to be dependent on the second one. It can't be the first one, because who cares? Well, the sum is dependent on both, but once we got the first event that happens, then the second one determines whether we get the sum of 7. Whatever. Okay, great. Good. Let's continue. Screen sharing is paused. Okay, there. Now let's return. Okay. So here's what I want to do. I want to go quickly to the restroom. And let me pause this. Oh, you guys are weird. Anyways, all right, so let's look through each one of these. It says, identify the 2 events that in the study, do the results indicate the events are independent or dependent? It says, here, researchers found that people with depression are 5 times more likely to have a breathing-related sleep disorder than people who are not. Okay, so what are the 2 events here that we are exploring? Okay, so depression and the sleep breathing related sleep apnea or something like that. Okay, so is it dependent or independent? It's dependent. So they're making the claim basically that I'm assuming that if you have depression, you have perhaps you have an influence on your breathing related sleep disorder. Maybe it's inverse. Like if you have sleep apnea, it could contribute to your depression or something like that. But they're definitely dependent. Pretty easy, right? Number 10 says stress causes the body to produce higher amounts of acid, okay, which can irritate already existing ulcers. But stress does not cause ulcers. So here we have what? Ulcers and what else? Stress. And they made it independent by making that last statement. Because the way you were reading, it's like, okay, so stress and ulcers have an effect. But because they said number one, which can irritate already existing ulcers, then we know they're independent. Ulcers and stress are independent. All right, number 11. Studies found that aspartame, an artificial sweetener, does not cause memory loss. So what are the two events? In the aspartame, correct. Independent or dependent? Independent. Independent. And number 12, according to researchers, diabetes is rare in society in which obesity is rare. In society in which the obesity has been common for at least 20 years, diabetes is also common. So what are the two events? And they're saying it's dependent. Does that make sense? Pretty straightforward? I think this is pretty easy. Okay. So I didn't really write anything there because I'm verbally speaking into here. So let's go ahead and get to the questions that matter. Oh my gosh, what happened there? Give me a second. Let me just use both my hands to. Okay, so here we have question number 14 of the homework, and it says pickup trucks. In a survey, 510 adults were asked if they drive a pickup truck and if they drive a Ford. The results showed that 1 in 6 adults surveyed drive a pickup truck, and 3 in 10 adults surveyed drive a Ford. Of the adults surveyed that drive the Fords, 2 in 9 drive a pickup truck. So the most important thing we can do for this question before we start reading the different sections they asked us is to convert each of those statements there into mathematical symbology, to some sort of, what the probabilities they state. So let me just, okay, there's 510. I'll just write it just for fun. N equals 510. We're asked if they drive a pickup truck and if they drive a Ford. So these people were asked, do you drive a pickup truck? And if they drive a Ford. So 2 separate questions. The results showed that 1 in 6 adults surveyed drive a pickup truck. So let's just go ahead and say the probability of truck is 1 in 6. 1 in 6. So we can write that. Then it says, and 3 in 10 adults drove a Ford. So driving a Ford is 3/10. Now, the last one is the most important sentence in this question because it'll allow you to be able to do the question or not. It says, of the adults surveyed that drive a Ford, 2 in 9 drive a pickup truck. So of the people that drove Fords, 2 in 9 drove a pickup truck. So the way you interpret this is as follows. You would say, well, the probability they drove a truck given that they own a Ford. That's how this is a conditional. And be able to understand that it was a conditional is what matters in this problem. Keep on doing everything the wrong scale here. Probability of truck is 1/6. Probability of Ford is 3/10. Probability of truck given Ford. Now remember, in this Venn diagram here, this part here means truck and Ford. All right, where they intersect. So let's answer question number A. It says find the probability a randomly selected adult driver drives. Sorry, find the probability a randomly selected adult drives a pickup truck, given that he or she drives a Ford. So this here is just that. We read it. We read that. It was this last sentence here. So didn't have to do any math for that. Now, find the probability a randomly selected adult drives a Ford and drives a pickup. So that's a more interesting question. So part B asks for the probability of drives a Ford and drives a truck. Now, if we look at the rule we had, the probability of A and B is equal to the probability of A times the probability of B given A. So therefore, the probability of Ford and truck must equal to the probability of Ford times the probability of truck given Ford. That's the way I do it. I kind of just apply the rule most of the time. Because every time you start overthinking these things, you start getting lost in your thoughts. So probability of Ford is 3/10 times the probability of trucks given Ford. That's 6/90. What's 15 times 4? Is 6, right? So 50, I'll say 60, but 15 times 6 will make 90, right? There you go. That's what I wanted. Thank you, though, because you're smart. I'm gonna go only if you're careful. So this comes out to approximately 0.07. And I know you can't see it, so let me slide it over though. Okay. We're good? Everybody's good? I see you guys writing, so I'll wait. Does it make sense what I'm reviewing? That's the answer for B. Well, 1/15 is better. It's 0.06666666 forever and ever and ever. It's just given the Ford. Given the Ford. Now, part C, I'm going to use rainbow color because I think rainbow color is good. It says here, are the events driving a Ford and driving a pickup truck independent or dependent? So are Ford and truck independent? And the answer to that is very simple. And before I get caught running out of battery, I'm going to go ahead and begin charging this tablet. it would be nice in the next iteration after the Pro 8 that they start improving the battery life of these tablets. I guess they're gonna have to go to the ARM architecture like Apple has done. Maybe there is an improvement in battery technology, but for now, it always seems that when you push these machines, they run out of battery very, very quickly. All right, there we go. It's charging. So it says F and T are and T are independent. Well, when are F and T independent? Well, remember, the probability of F given T equals the probability of F, or the probability of T given F equals the probability of T. Well, we don't have access right now easily to Ford given T, but we do have access to T given Ford, which is 2/9. Does 2/9 equal to 1/6? Does 2/9 equal to 1/6? No. So then therefore that's how you show that they're dependent. Because if they were equal to each other, then it would be independent, but they're not. The conditional and the regular event are not the same, therefore dependent. If they were the same, then it would show that the first event had no effect on the second event, and that would show independence. Does that make sense? So we're using the definitions we were given. Make sense, people? Yeah, because Ford had an effect of the probability of the truck. Does that make sense? It's very important you understand this. I'm lassoing. Oh no, wait. I don't want to lasso that part. Give me a second. Let me see if I can lasso this so I can create a little bit more space. Are none of your teachers using this? No? I keep on saying that all the time. But they should start using this. How would you use this in English? You wouldn't use this in English, right? There's no way. So I moved everything up. Okay. Questions or concerns on number 14? Did it look pretty straightforward? Okay. And so now let's wrap it up with number 15. And then I'll record the time when I finish this lesson. Update this to Teams. Are you guys even looking at the videos I put on Teams? Probably not, right? Does anybody have a good reason why they didn't do the homework that they want to discuss with me, or like to elaborate on the plan? Obviously, we had a death in the family because of Corona. I can understand, but if like you were just watching Family Guy or something like that, you guys watch Family Guy, right? Tampoco? Okay. You play video games? Which game did you play? How many hours did you invest in Mario Kart? In Animal Crossing?
Yeah.
Man, video games, I understand, but bro, you know what? Oh. All right, sorry, I got a text message that stop playing video games. Save it for the weekend. You know what? Save it for the weekend, and also try and see if you have to earn your time to play a video game. How about that one? Would that be better? Okay, good. So after you complete, I don't know, a 10-mile swim or something like that. Why? Okay, 1 mile. I know. All right, guys, let's take a look at summer vacation. It says that the table shows the results of a survey in which 146 families were asked if they own a computer and if they will be taking taking a summer vacation. So here we have own a computer, yes or no, or summer vacation this year, yes or no. Says find a probability a randomly selected family is not taking a summer vacation this year. So let's look at it for a second. See, this yes and this no will be ownership of a computer. So we know we can see there that how many people own a computer? 57. How many don't own a computer? 89. Now up here is a yes or no for summer vacation. How many people took a summer vacation? 100 and? How many people did not take a summer vacation? 45. Okay. How many people then says here, find a probability the random selected family is not taking a summer vacation? Wait, it's raining. Let me close my windows. Okay. So what's the probability of not taking a summer vacation? $45 over what? And you would be completely correct. So remember that squiggly line means not. Super easy. By the way, what's the probability, just because we could do it, of taking a vacation? 101 over 146. Just for the giggles, what's the probability they own the computer? No, just own computer. 57 out of? And what's the probability they don't own a computer? Out of? And you can't see it, but whatever. It's over there. All right, then says here, find a probability random second family owns a computer. We already said that the probability of it owns a computer is what? Out of? Super simple, right? So far, so good. Now it says here, find the probability random second family is taking a summer vacation this year, given that they own a computer. So the probability they take a vacation, given they own a computer. Okay. Let me read it another way. Probability vacation if they own a computer. Given, so look, which own a computer is here, right? How many people own a computer? 57. How many of those took a summer vacation? That's what a conditional means. In English, I guess, or computer science, we have if-then statements. I guess this is sort of like an if-then statement. You see that? The probability of vacation given computer. Now, what about probability of computer given vacation? If we did that. So computer given vacation, here is given vacation. There's 101 people who took the vacation. Of those, 46 of them own a computer. You see that? You see how it worked? The one on the bottom, not the bottom, but the conditional after the given, after that line, determines which row or column you're going to focus on. All right, so that this is. Yes, I do. Likewise. Look at D. Find the probability a randomly selected family is taking a summer vacation this year and owns a computer. So what's the probability they're taking a summer vacation this year and a computer? Well, let's take a look at it. We can do this by inspection. We can do this by inspection, meaning there it is. Vacation, yes. Computer, yes. That's 46 out of 146. Or if we want to show some math prowess, we say it's a probability of vacation times the probability of computer given vacation. Probability of vacation is going to be 101 over 146. The probability of computer given vacation, which I took out, but I'm gonna write it up here just because the probability of computer given vacation was 46 out of 101, right? We had that written. So we're gonna multiply 46 times 101, and then we end up with these canceling, and you're left with 46 over 146, which is the same thing we got through inspection, through just looking at the table. The rule works. Now, the final one, are the events owning a computer and taking a summer vacation this year independent or dependent? And the way you would do this is, here's computer and vacation, right? You would just check if the probability of computer equals the probability of computer given vacation, or you can look at probability of vacation. Does it equal the probability of vacation given computer? So if they are equal to each other, it would be independent, else they would be dependent. So computer would be 57 out of 146 equals, does it equal 146 over 101? So it's dependent. I mean, and if you want to be extra, the probability of vacation is 101 over 146, and the probability of vacation given computer does not equal the same thing. It's dependent, and that's how you would show dependency. Only if you're careful. So guys, I think I put in a pretty decent effort. Please, it's a new year. Every day is a new day. Please, I know it sounds corny. I know that I'm perhaps a hypocrite, but you need to do your homework.